So we will see. I'm not sure if this analogy helps, but let's go through it. You have crafted the perfect look. You took out your cell phone while you were not in math class. You took up Instagram. You created a story. Here's the math part. You got some likes, on your story. It was very popular. So think of this as a function. What was the input? Instagram is the function. What's the input? What? The photo, okay? And the output was I created a what? What did I create on Instagram? A story, okay? So the input was the photo. The output was the story, okay? So that's just a function. We don't run into functions like that in math, but let's go a little bit further. You're trying to keep in touch with the old crowd, so you link your Twitter to your Instagram, okay? So, because I want to take the post from Instagram, my story, and I want to use Twitter to turn it into a, what does Twitter produce? Tweet, okay? So, what is the input for Twitter? Twitter takes as its input what? The story from Instagram, and it creates a tweet, okay? So I got two functions here. One function was Instagram, the other function was Twitter. So what did I do with these functions? I didn't add them together. What did I do with these functions? I didn't add or subtract or divide. What did I do with these functions? I what? I didn't multiply. I what? Yeah, I did them I did one and I applied them both consecutively. I applied one function and then I applied another function, okay? So in mathematical terms, we'll get to see that in just a minute, but so it's very clear that I started with one function that took a photo, created a story on Instagram. The next function took the story on Instagram and created a tweet. So these functions happen one after another. Which function happened first? Instagram. And then the output of Instagram happened on Twitter. So I had two consecutive functions happening at different times. So let's look at this. What was the domain? Remember the other word for domain is input. What was the input for Instagram? It was just your photo or your selfie, right? What was the output? Instagram created a what? Created a story, okay? Okay. And then what was the input for Twitter? It took the story from Instagram and it created what? A tweet, okay? So the output from Instagram became the what? Input for Twitter, okay? So that's what happens when you apply a function twice in a row. You're going to have create the output from one function becomes the input for another function. So in mathematical terms, this is what happened, okay? We start from the inside and we work our way out. I started out with a photo on my phone, and then Instagram turned that into the story, and then Twitter took the story and turned it into a tweet. So when you have functions that are embedded in each other, you want to look to the inside first, okay? Because I can't, like if I look at this, I can't create the tweet until I have the what? Story. So I had to get the story first in order to make this function work, to make these two functions work together. So now let's get out of the social media land and look at it in a little bit more boring terms with math. So I got two functions, f and g. And there's notation here that you're going to need to really know. This notation f, and see this little open circle, it looks like a degree sign. This means f composition g. It means f, so f composition g of x, it just means f of g of x, okay? So that's different than this. What does this mean? What is that? Yeah, this is multiplication. This is f of x times g of x, and then this notation right here, that's f of g of x. That's embedding the functions together, okay? So when you see this open circle, that operation is a composition, okay? So let's get a little bit of example here. I've got f of x is x plus 5. G of x is x squared plus 1. I want to find f of g of x. I'm going to do it over here in the white space here. So f composition g of x, these all mean the same thing. all that means is f of g of x. So f composition g of x, f composition g means f of g of x. That's what this means. So which function will I start with? I'll start with g. Remember, like Twitter and Instagram, I'll start with this one, and then it gets plugged into the other one, okay? So this is the inside function, the innermost function. It gets plugged into f. So x goes into g, and g goes into f, okay? So let's do this. Now, the way we figure out this operation, I'm going to write down what f of x is. So real easy. What is f of x? X plus 5, okay? Pretty simple, right? All I did was copy it down. Now, we've done this before when we were doing even odd. I'm going to write it, and I'm going to replace the x's with blank parentheses. Remember, we've done that before. And I'm going to do it twice so that in your notes you will go back and you will see what I did. Okay? Now, what needs to get substituted into f? G. Okay? So I need to be able to plug g of x into this equation. Okay? What is g of x? What's the definition of g of x? Yeah. So f of g of x is x squared plus 1 plus 5. So all I did here was f. Here's f with blank parentheses where all the x's were. And this is me plugging g of x into those blank parentheses. So now what do I do? Can this be simplified? What is this? X squared plus 1 plus 5 is what? No. X squared plus 1 plus 5. What is that? X squared plus 6. Okay. So f, we're waiting for people to wake up. It's not as hard as it seems, okay? F of g of x is x squared plus 6. Okay. So that is the composition. So we say that f composition g is x squared plus 6. Another way of writing that is f composition g. Okay? So that says you work with g, and then the results of g get plugged into f. Okay? What if I were to come over here and say, is that different than g composition f? What does g composition f mean? It means g of what? It means g of f of x. Okay? I'm going to follow the same procedure I did over there. Let's write down what g is. G of x is what? No, I think it's x squared plus, oh, you're right, x squared plus 1. Or is it, yeah, sorry. X squared plus 1, okay? That's what g of x is. And now I'm going to rewrite it, replacing all the x's with what? Blank parentheses, okay? I tend to write it twice so that in your notes you could go back and see what I did. Now, what needs to get substituted into g? F of x. What is f of x? X plus 5. So this tells me that g composition f is x plus 5 squared plus 1. So this is the function you get from g composition f. Are they the same? F composition g and g composition f? No, they're different functions. Okay, so the order mattered in which way I performed that operation. Okay, this is similar to what we were doing when we did even and odd, when we had to substitute f of negative x, negative f of x. Okay, plugging things in. Okay, so all you're doing is you're plugging one function into another function. Okay, let's do a few more examples of this. Yes. Yeah. Right, so like this. F composition G, you might have to say, what does that mean? That means f of what? F of g of x. That's Right, this might need to be put down there. That's what this means. F composition G means f of g of x. Okay? Now, what did I do? How did I start? How did I start all those other problems? What was the next thing I did? I wrote down which function? Nope. F. I know. F of x. What is f of x? F of x is x plus 7. And then I rewrote it, replacing all the x's with what? Open parentheses. Okay? Because I need to substitute something in there. And just for your notes purposes, so you can see that's what I did, I always write it twice. And then what needs to get substituted into f? G. What is g of x? Yeah, so over here I write x squared minus 1. So f composition G is what? X squared minus 1 plus 7. Now I get the question, can I leave it like that? I think you can go a little bit further. What is this one? Yeah, this is just x squared plus 6. That's f composition G. You can do that. You can call it fog or goff or whatever. You can do that. Of course, I made the mistake my first year of f composition K, so I try not to do that one. So anyway, you could draw that for your. Anyway, we'll move on. And I am recording today, so sorry about that. G composition F. What does G composition F mean? Yeah, this is G of f of x. What was the next step that I wrote down? What is G? So G of x is what? X squared. Is it x squared minus 1? Okay. Yep.
Just to make it clear, it might be stupid, but so whatever like letter, like if it's G on the outside, then you're gonna do G first. If it's F on the
Yeah.
first,
This is the outside. That's the inside.
yeah, but like if like for this one we're doing G first, and then for the last one we're doing F first.
Because it was on the outside.
Yeah.
So you always take the one that's here on the outside, write it down first, and then rewrite it with parentheses. Okay? So this means that G, what needs to get plugged into G? F of x. Okay? What's f of x? X plus 7. Okay? So that tells me that this is x plus 7 squared minus 1. Now some teachers will make you multiply this out. I don't, because we just spent a whole unit, taking stuff that looked like this and getting it to look like this. Why am I going to make you, I'm not going to make you multiply it out because there's nothing else to do with it. Okay, so I'll trust you on that one. Okay, H composition F. What does H composition F mean? Yeah, it means H of f of x. Okay, what's my next step? Which one do I write down? Yeah, H of x. What is H of x in this problem? Is it square root of x plus 2? Okay. So now I'm going to rewrite this, which is open parentheses, or I can just leave that open square root. Okay. Now, what needs to get substituted in to H? F of x. So what is f of x? X plus 7. Okay, so H composition F is just the square root of x plus 7 plus 2. In composition F, what does this mean? Okay, so which one do I go write down first? N of x. So n of x, what is n of x? X cubed minus 2. Okay, So then I write it with blank parentheses. And what gets substituted in is f of x, right? Which is what? X plus 7. Okay. So that's my answer. In composition F is x plus 7 cubed minus 2. Okay. Pretty straightforward. No, it's just, I mean, if I just see that that's your answer, that's what I'm looking for. Okay. I'm looking for that to be your final answer. Now, let's switch gears a little bit. I was finding the algebraic expression, for n of f of x, okay? What if instead of knowing the algebraic expression, I only wanted you to evaluate it at one specific point, okay? So f of g of 2, okay? Let's start from the inside. This says plug 2 into which function? G. You're going to get a number. What are you going to do with that number? Substitute it into f, okay? So to do something like this where I ask you for f of g of a specific number, first find g of 2. What is g of 2? G of 2 is going to be 2 squared minus 1, which is 4 minus 1, which is what? This is 3, okay? So now this number needs to get substituted where? Into what? Into f, okay? So f of 3 is going to be 3 plus 7, which is 10. So this one's just a little bit backwards, that you start with the inside. If you're looking for a specific evaluation, start with the inside number. G of 2 gives you a number. That number gets plugged into f. So 10 is f of g of 2. Okay. Okay, g is x squared minus 1. So g of 2 is 2 squared minus 1. That's 3. And then plug this number into f. F of 3 is 3 plus 7. Okay. Let's do another couple of these. So h of 4, I need to find h of 4. What is h of x? Square root of x plus 2. That means that h of 4 is the square root of 4 plus 2. Okay. What's the square root of 4? 2. What's 2 plus 2? 4. So h of 4 equal 4. Okay. Now, what number needs to get plugged into? Where do I do with this number? This plugs into what? G. So I need to find g of what number? G of 4. So g of 4 is going to be, here's g, 4 squared minus 1. What is that number? 15. Okay. So g of h of 4 is 15. H of n of 3. What do I find first? Yeah, n of 3. N of 3 is, here's n, so that's going to be 3 cubed plus 9. What's 3 cubed? 27. So this is 27 plus 9, which is what? 36. So n of 3 is 36. And this number has to go where now? Into h. So h of 36 is going to be what? The square root of 36 plus 2. What number is that? Ocho. There we go. Question? You got it? Okay. So this is, like I said, it's one of those things that it needs to click because it's not that computationally hard, but you can see if this wasn't clicking, you wouldn't know what to do. Okay. Now this one, don't let it confuse you. F of 3. What do I need to find first? Find f of 3 and then plug that number back into f. So what is f of 3? What is f of x? Yeah, so f of x is x plus 7. So f of 3 is what? 3 plus 7, which is 10, right? Now, this number needs to get plugged into what? Plug it back into f again. So f of 10 is going to be 10 plus 7, which is 17. What is that, siete? N of 0. What is n? What's the function n? Okay, so this is 0 cubed plus what? Plus 9. Okay, what is 0 cubed plus 9? 9. So this is 9. This number needs to get plugged into what function? G. So g of 9 is, what is g? Yeah, so that's going to be 9 squared minus 1, which is 80. H of g of 0. Okay, what is g of 0? So g of 0, what is g? Oh, it's, yeah, so this is 0 squared minus 1, which is negative 1. This number now needs to get plugged into what? H. So h of negative 1, and h was square root of x plus 2. Bells are going off in your head at this moment because what are we trying to do? It's not a real number. So there are no real solutions here. You can just write undefined or no real solution. Okay. Well, there are complex solutions. You know that. So that's where you were going. That's what was throwing you off. Okay, the next one is just to see if you've been paying attention. Is this one harder? What will I do on this one? Find h of 0 and plug it into g. Take that number and plug it into, yeah, okay. So h of 0, what is h? Square root of x plus 2. So this is the square root of 0 plus 2, which is 2, okay? That number needs to get plugged into what? G, okay? So g of 2, what is g? So it's 2 squared minus 1. That's 4 minus 1, which is 3. This number now gets to plugged into what? Into f. So f of 3 is what? 3 plus 7 or 3? What is it? 3 plus 7, which is 10. Okay? Pretty straightforward, right? Okay. No, this is not it. We got more to do. So, I saw this picture. F of x is what? G of x. This is f of g of x. Because what happened? What happened? How many of them, this is pizza or this is like, this is good? Okay. Okay, y'all can leave. Okay, so this is f of g of x because what is on what? What got plugged into what? The pineapple got plugged into the pizza. Okay, so this is f of g of x. This is g of f of x. This is the pizza put into the pineapple. Okay, so okay, I can go with this one. This is just nasty right here. This is pizza on pineapple. So this is f of g of x says put the pineapple on the pizza. You know, and then gosh, what happened here? And then g of f of x says put the pizza on the pineapple. These are two different things, okay? If that will help keep it straight for you. So what I want you to do now, let's look at another example here. So take one of these, take one of those and pass it around. So let's look at this. Okay, I did this yesterday. This is our break. I did this yesterday and people thought this was true. This is all fictitious right here. Okay. Yeah. Apple has decided to offer two promotions on the AirPods Pro. The first is a 30% off to Woodward College algebra students, and the second is a $10 off coupon for the class of 2020. The retail price is $250. Okay. We got two functions here. We have a discount. If you get 30% off, what percent are you paying? 70%. So this is my discount function. Give me the original price, and you are going to pay 0.7 times that. The coupon price is take whatever price you have and subtract what? $10. Okay, so the coupon function is whatever the price is minus 10. Okay, so what does this mean? C composition D. What does that mean? It means what? No, function what? It means C of what? This is C of D of T. Okay? C composition D. That means C of D of T. Now, if you look at this, what happens first? What happens first in this thing here? The discount or the coupon? So you get the discount first, and then you get what? The coupon second. Okay? Do you want that, or do you want it the other way around? This function is D of T instead of D of X. That's my variable. Okay? So that's C of D of T. What is this function here? What is D composition C? What does that mean? This is D of C of T. Okay? My C doesn't look quite right there. So what happens first here? Guys, what happens first here? And then what happens second? So we want to figure out which of these is to our advantage. Okay? So let's go back up here and figure out what this function is. C of D of T. Okay? What did I do? What did I write down first when I was trying to figure that out? I wrote down C, the outside function, every time. So C of T is T minus 10, right? And then I rewrote it with what? Blank parentheses. How many times did I do that? Yeah, to maybe think that it would take. Okay. What needs to get plugged into C? D of T. What is D of T? Yeah, 0.70 times T. Yes. When you're evaluating at a specific number, you plug in that inside number first. When you're trying to find the expression for all values, that's the way we started out the class. I always started with the outside function, and then I plugged that inside function in. Okay, so this tells me that C of D of T is whatever this 0.70 T minus 10. Okay, so here's the expression for C of D of 10. Okay. Now, if I want to know what C of D of 250, like if these AirPods start at 250, which one do I find first here? I find what? D of 250, and then I plug that into C. So let's find D of 250. So D of 250, that's the discount function. So that's what, 0.7 times 250 equal 175. Okay, that needs to get plugged into which function? C. So then C of 175, that's my coupon function that does what? 175 minus 10, which is 165. So in this problem, the first way, you're going to be paying $165 for the earbuds, okay? Now let's do it the other way around. D of C of T. Let's find the expression for D of C of T. To find the expression, I always start with which one of these? I start with D. D of t is my discount function. I rewrite it twice with open parentheses. And then what am I going to substitute in there? C of t. What is C of t? T minus 10. Okay. So this is my expression for D of C of t. Okay. If I want to evaluate this at 250, what do I do first? Find C of 250. That's going to be what? 250 minus 10, which is 240. Take that number and do what with it? Plug that into D. So D of 240 is my discount, so 0.70 times 240, and $168. So, what would you prefer? Not a whole lot of money different. What was the first number we came up with? 165. If this is your money and not your parents' money, which one would you want to do? 165. There you go. Hopefully those were the same answers, your money and your parents' money. So what do we want to apply first? Yeah, so the better thing would do the discount than the coupon, okay? So it makes a difference which order these two things happen.
How do we know what to do? What order to do?
What do you mean?
Like, how do we know, like, start in the center?
Okay, if you're looking for a specific value, start in the middle, find C of 250 and plug that into D. If I'm looking for the expression for all values of the variable, that's where I do this thing where I write down the outer function first, blank parentheses, and then plug the inner function in, okay? So if you're looking for a specific value, that's when you start from the inside. If you're looking for the expression for all values, that's where you're going to start with the outside. So let's do one more example before I turn you loose here. Let's look at this guy, okay, F, G, and H. I won't do all of these, but what does F, composition G, fog, what does that mean? If you write that it means F of X times G of X, there's just no credit on the test for this one, okay? That's missing the entire concept. This means F of G of X. What would it look like if it meant multiplication? What kind of dot would it be in between these? A solid dot, okay? The open dot like there, that degree looking sign, that means composition. Okay, to find this, every time that I did this, what function did I go to next? Which function did I start working on? F. F of X is 2x plus 7. And I'm going to need to substitute something into that, so I just rewrite it with all the x's replaced with open parentheses. What needs to get substituted into F? G. So G of X is what? X squared plus 3. Okay. So this is my answer. F of G of X is 2x squared plus 3 plus 7. And I don't, you could, if you want to go and spend extra time writing this as 2x squared plus 6 plus 7, you can do that, but I'm okay with this, okay? This is the correct answer. How does that differ from G composition F? What does G of F mean? Yeah, G of F of X. So which function do I start with? G. So G of X is equal to x squared plus 3 What needs to get substituted into G? F of X. What is F? What is it, 2x plus 7? That is G of F of X. Okay. Now, where this differs, let's move on. I'll skip this next one. When I'm asking for specific values right here, if I want to find F of G of 2, this is where I start in the middle. because I want to figure out what g of 2 is and then plug that into what? F. So what is g of 2? G of 2 is going to be what? 2 squared plus 1, which is 5. So g of 2 is 5. This number has to get plugged into what? F. So f of 5 is equal to 2 times 5 plus 1. This answer is 11. Okay? Does that feel okay? So that's the difference. When you're looking for a specific value, always start on the inside. Okay? So you've got time. You can. Let me go to this next one. We'll do that bottom one there in a minute. Let's do that before we end, just so it does not overwhelming. What do we need to do here? F of g of h of 0. Find h of 0. So what is h? What is h? It's what's square root of 0. So it's the square root of 0 plus 2. What is that number here? That's 2. That number needs to get plugged into which function? G. G of 2 is what? X. What's G? X squared plus 1. So that's 2 squared plus 1, which is 5. That number needs to get plugged into F. F of 5 is, what is it? 2 times 5 plus 1, which is 11, right? Okay, so you're just repetitively applying functions. That's all the composition really is. I want you to omit a page. So go over here, this next page. You can omit this. And we're omitting the next section. You know how when we were adding and subtracting, I always ask you to find the domain. The next section is using your calculator to find the domain of compositions, and that gets very complicated. So we are skipping that. So we are skipping, what's the next section? 5.3. Anytime this semester it says use the TI, we're skipping that for the fall. We'll be using the TI in the spring. Yeah. No, you still need the skill of finding the domain, okay? So if I look, guys, at your homework, it is still, guys,